All right, welcome, ladies and gentlemen, to day 5 of the recap for the open office hours. I have been calling this the office hours because I have not been in the classroom teaching this week. This has been the first week of trying to get our virtual learning kind of set up. Some good things for at least myself as a teacher. I have a lot of the videos and organization already prepared for my students. The bad thing is many teachers do not have that prepared, or students are not used to kind of learning in an online setting. And I mean, even my students, I provide all my videos as a supplement for them, nothing for them to actually go ahead and learn from. So I kind of spent this week kind of getting all that set up. We're still trying to learn a lot of the management system that we're going to be using to continue the online learning, because for me, that's, it's new completely for me as well. So I just wanted to kind of spend today just kind of doing a recap, just kind of let you guys know how things kind of worked out on my end, some things that I've been thinking about and what I'm going to be doing for next week. And I also just decided, the other thing too is it's a Friday evening, but it's like I have nothing else better to do, because I was joking with my wife. I'm like, what do you want to do tomorrow? Like sit around and entertain our kids again? It's like, yeah, basically, one of us will work, the other one will work. That's kind of how the week is gone. And then the other one's usually, playing with the kids or doing something exciting. So, or maybe one of us will do a trip just to like get out of the house. Just to kind of walk around. So it's kind of like been our reality in that case. And then, so at first I was like, I'm not going to do Friday night. Like, why would I do Friday night? But it's like, well, I don't really have anything else better to do. And I've been pretty consistent, at least this week. This has been my 5th live stream that I've been able to go through for this week. And I've just kind of decided it's become a decent rhythm for me. I think as long as I can keep myself under control from my chatter, that we can continue this continue this on as long as we're doing our virtual learning. So I do see Anthony back in, Mark, Justin, Addie. Let's see, pulling the strings. Yeah, I know. Boom trees and stuff like that. So good to see you guys back on. And yes, you are going to get Fridays off, Mark. A couple things. So I do have, I did want to kind of let you guys kind of know. So I will be planning on doing live stream. What I want to, I started recording some content for my students, but in reality, since their quarter has been pushed a couple weeks, where I'm actually not going to be distributing any of that kind of material, but I at least will be kind of doing some review. I do have some older videos that I recorded for them that I didn't upload on my YouTube channel. So I'm going to go ahead and do that. But what I decided to do, because I think it would be kind of weird for me to, I have like a ton of videos from me teaching inside the classroom that I'm just not going to release, because I think it's just kind of weird since I'm obviously not in the classroom. But I think what I'm going to do is to kind of keep a schedule going on for right now for this distance learning. I am going to release all of my lecture videos on Tuesdays and Thursdays. So I think that'll just kind of be the easiest to do. Tuesday and Thursdays would be my kind of lecture videos. And then on Saturday, I'll just plan on doing a random kind of worksheet. If you've kind of paid along my channel, you've noticed that, sometimes I'll do these random worksheets of me doing like 12 problems. I did one this week of like completing the square. It's a worksheet that I created that, I had on like a course that I created on Udemy, but I never really did anything with it as far as like making a video or an answer key. So I just decided, let me just kind of work through these old worksheets. And if somebody wants help with a particular concept, then, watching me do that concept 12 times in a row, hopefully we'll go ahead and help them out. So that's what we'll be doing for these upcoming weeks as far as doing digital learning. So I'm going to plan on releasing the content during the day and then just kind of going live, answering your questions. I am also going to I'm going to put the answers on Discord. So therefore you guys can start communicating that. I didn't get that set up, but that's something I'm going to work on for this weekend. So therefore I'll still kind of post something at the beginning of the week, but then just let you guys know to put everything on Discord. So therefore we can kind of follow along and kind of continue the conversation on that way. And I think that will just kind of help out for students being able to post, pictures, of their work and stuff like that. And also for people to be able to comment and help each other out. Whereas when everybody's just doing it on the community chat, it's not really as easy to kind of do that. And then also we can kind of keep things organized for every week. So I think that will just kind of be the best. All right. So see Samir and First Bank. Whoa, sleepy edits. Ronaldo, for a long time, don't see. Any trouble finding the channel? Okay. So let's go ahead and get into the, oh, well, I do have a couple other questions, but I'll get to those. Let me just go and get to the math. If you guys do have a math question that you do have, I recommend putting it into the chat. I'll try to see what I can go ahead and knock out from there. I'll try to see what I can knock out. What this question is, do you use mapping notation when graphing functions? If no, why not? I'm not really sure. It's been a how to like best explain that, but you know, I'll kind of talk about the mapping of kind of like a function. And I guess you could kind of think about it like as graphing or not, but I'll talk about mapping and just kind of going from there. At least how other ways we can think about this, because typically it's not used to graph, to represent a graph, but we could definitely go ahead and alter some things so therefore we can understand it. All right, but yeah, I'll just kind of answer these two questions. I know obviously many of you guys are not like into or in need of like a math, like you have a test tomorrow, because we all kind of know that that's not happening. So therefore I'll just kind of cover these just to kind of give you a quick little refresher, talk about them. And then I do have some other things that I do want to let you guys know of what I'm also going to be doing, or what you guys are going to be doing actually for next week. So the first one is just an understanding of how to convert between exponential and logarithmic functions. So, I think one of the best ways to understand logarithmic functions is to understand exponential. So, most students understand 3 squared equals 9, right? Because that's 3 times itself. 3 times 3 is equal to 9, right? Now, so we know this answer. We know 3 squared is equal to 9. We agree with that. 3 times 3 is equal to 9. Well, what if I just wrote the problem then with the variable, like 3 to what value x is equal to 9, right? So now if I said, well, what if I wanted to solve for x? Now, obviously here we already know this answer, right? But what if we didn't know the answer? What if it was like 2 to what number equals 9? Like, how would we go about in solving that, right? When we want to solve for like x, for instance, if this was, x squared equals 9, if I want to solve for x here, I'm going to use the inverse operation of, squaring, which would be the square root. So x would equal, plus or minus 3. So then what's the inverse operation here of this power, right? Well, of an exponential function, well, that is going to be the logarithm. And basically what we're going to do is we're going to take the log of base 3 on both sides. Now, you could do the log of base 3 on both sides, or a lot of times we just talk about this conversion between exponential form and logarithmic form. And basically that is what a logarithm kind of allows us to do, is allows us to write this problem in solving for x. So if I wanted to solve for x, I can use logarithms to say 3 base of 9. So without getting into the rules and explaining everything basically what the logarithm is asking us is 3 raised to what power is equal to 9? And that answer is x. Now, obviously we already know this answer is 2 here, right? But in this case, you can see like why the logarithm function on your calculator could be beneficial, right? Because we don't know, like if I was going to say x equals, log base 2 of 9, like log of what number, 2 raised to what number equals 9? Well, 2 cubed is 8, right? 2 to the 4th is 16. So we definitely know it's going to be some decimal. That's how that, that logarithm can be helpful. So a couple tips as far as converting between these two forms. So basically this is our logarithmic form and this is our exponential form. A couple things that I would just say to recognize here is that the base of your exponent is 3. The base of your logarithm is also going to be 3. So you can say 3 to the x equals 9 and then log base 3 of 9. And then obviously you want 3 raised to whatever that value is equal to 9. So it's going to be like, a lot of times you can say like circle over, like if you just kind of do like a nice little circular kind of curve, then you can just connect the 3 and the 9, and you can see those are going to be your two components of your logarithm. So not the best in-depth explanation, but hopefully that kind of gives you at least over the hump as far as how exponential and logarithms are related. Now, on to the next question, which is just kind of talking about mapping. And so there's a couple different ways we could use mapping. We could represent these as like the input and output, which is a lot of times how they are represented is, to say, all right, this is the input and this is the output. Okay. And they're basically just saying like, if you plug in 1, you get out, 5. If you plug in 2, then you're going to get out, 8. If you plug in 3, then you're going to get out 11 or whatever may be the case. Now, the problem is we don't know how is it going from 1 to 5, 2 to 8, 3 to 11. Like, what is that rule? Well, that rule is what we call the function, right? And so that is going to be, when you look at like a function, like you have f of x equals, this rule with the input variable. So that is going to be your input, and this represents your output. And whatever you're doing to your input to get to your output is basically like your rule, like your linear, quadratic, logarithmic, exponential. It could be anything. So the mapping doesn't really tell you what's going on. It's just telling you what the input and the outputs are. Now, if we were to think about this in function notation, like x and f of x, then you could represent this on a graph. So you could use mapping to represent a function, right, as these dots. Now, but again, though, this is just a table of values. We don't know what the rule is. We don't know if this is a continuous function. So in this case, I would just be plotting the points. 1, 2, 3, 4, 5. Right? So whatever my graph is just going to look like, I don't know, I'm just going to make something up. We don't know. We can't connect them. The only things we know is the values 1, 2, and 3 for the x values, for the inputs, and then these values 5, 8, and 11 for the output values. Now, again, just a review. The big reason why mapping is kind of helpful because it gives us that visual of when we don't have a function. And we don't have a function is when we have like an input value of, let's say, I don't know, 3. And from that input value of 3, we get like 2, and then we get -7. Well, now we have an input that is producing 2 outputs. So therefore, that is not going to be a function. So that's what it primarily, mapping has been most useful, at least I've seen, and helpful as far as giving students a visual as far as when we have something that is a function or not a function. In graphical terms, we're usually typically looking for like that vertical line test and so on and so forth to be able to distinguish between a function or not a function. All right. Hey, Elena, good to see you join on the stream. Happy to have you. I don't remember the formulas. I can't make you guys make sure you're making me remember all these formulas. Jeez, oh man. Hey, Brian, have you ever played Wizard 101? I have not. I do not know. Just trying to learn math. Well, that's very good. Bleach God. Hi, Laura. All right. Good for my students. I teach pre-calc and integral math. Kimberly, if you have a chance to make a video showing how to set up a whiteboard and the apps you use. Yeah, you know what, Kimberly, I was thinking about doing that. As far as like I know a lot of teachers like that I've kind of been following along, like, you know, seeing what they were doing. Cause obviously, like, I remember when I first started doing this, it was just, I remember searching on Google so many times trying to figure out, like, I could not find the right app. And I remember there was a couple teachers that were teaching off of this app, and I like could not, I was trying to like, I remember like look at their fonts. I'm like, what app is that? And I could not figure out. It was so frustrating. So I definitely understand, you know, what you're going through. Trying to figure that out. And I've seen a lot of what other teachers are doing from on there. And I think there's a lot more resources out there. I'm not sure if like my setup is obviously the best. Like I can, you know, obviously I'm happy to share, like I just use a Notability app. Obviously I work on a MacBook Pro, but obviously you could do this on a, you know, any iPad. And just get it from the App Store. It is a paid app, but I've been very pleased with it because basically not only can you upload the PDFs, but you can save them as the PDFs, and obviously you can annotate them. I do use a tablet pen to do all my writing, which was really weird. I did not like doing it for the longest time. But that is something that I just kind of gotten used to so far with that. But I know a lot of time I was really resistant. I really wanted to use like my iPad and just write on my iPad. But I think it's been helpful to, especially if you're going to do on the camera, to be able to write and then also to be able to give eye contact. Whereas some videos I've seen where people are like writing, and that's fine. If you're just doing a screen share, I think it's whatever makes you comfortable. But I've also noticed when I was doing, even trying to do screen share, like kind of keep my like fingers out of the way. It was just kind of like always weird. And then, then your hand would like nudge on things and mess everything up. So using the tablet pen has actually been very, very helpful. Even though my penmanship is not great and the tablet does not help in that regard. But so I use Notability and then I use ScreenFlow, which is a paid app, but I like this paid app because I can edit off of it. But obviously, if you are just working on getting something to your students, there is a ton of free apps. I also use Screencastify for a lot of times when I just need to share something that I'm doing on my computer. And that is obviously with all connected with Google. So I definitely recommend that. And there's a lot of other great apps that I would say, test out. But I will say there was, I did always look at I'm always hesitant to give recommendations just for the one fact of, I've also been through a lot. I've also tried a lot of things. And even though somebody would recommend it, I'm like, this doesn't really fit the way I want it to, or I don't really like it. So it really just kind of came into there. I got to try a lot of things. And the nice thing about anything that's typically free or definitely paid for, a lot of them do have free trials. And I just recommend it. It really stinks because you do have to spend a lot of time trying things. And it's much easier if just somebody tells you do this or use that. But I really do think that, just that, getting used to different, because I didn't decide on Notability or ScreenFlow until like after I've tried like 3 or 4 things. So for each of them, for screen sharing as well as for, whiteboards. So, I think if you automatically just go with one, you don't really know what else is out there and you might actually work a little bit better. So I think it is a little bit of recommendation. So that's why I'm happy to give my recommendations, but I'd also recommend back to you to try some other things out, see what other people are using and see if they are going to be better. Because obviously from the time that I started to what is available now, it's going to be a little bit different. And there's going to be definitely a lot more options out there that might be better suited for you. So hopefully that helps and did not need to go in more in depth as I did. All right. Hi, Victor and Capena. My question is, can you solve using cross multiplication? What? But something went wrong. Well, I'm not really sure, but I know that cross multiplication is typically where a lot of students will make some mistakes. So I would say just be very, very careful with that. Aiden, geez, oh man, you guys are crazy. Used to struggle in math growing up. I would never have thought. Well, yeah, Victor, and it's that is very much true. I have the grades to prove it, and the and also the report card to prove it. And I think one of the things that is important about like struggling with math or like not struggling with math is like, not staying with that label as like I'm good at math or I'm not good at math. Like I think we all struggle with math. It just depends on, at what level, like you're always learning, and I think that's the greatest thing about mathematics is there is no end. It's kind of like being like, oh, I'm the best, basketball player. Like, no, you're not, it's always a constant. You always constantly have to go ahead and prove yourself. And like mathematics, like there's always something else for you to go ahead and learn. But it doesn't matter. Like you're not in a race against anybody else, and there's so many things that every single time I'm teaching math or like working through math, I'm always understanding something a little bit more. And I feel it's obviously getting better. Somebody even commented today, like, you're so smart, you're so good at mathematics. And I'm like, you have no idea how many times I have solved the exact same problem over and over. Think about my life. I wake up, I'm doing math problems in the day, and then I'm going home, and then I'm grading math problems, and then I'm doing math problems, preparing for my lessons. And I'm like, when you do math that many times, like, of course it's going to come natural and easy to you. Right. And so, but again, like that definitely was not always the case, when math was not the front and center of my mind, like where I could care less about mathematics, like it didn't click with me. And I guess, I'd say maybe I struggle with math because maybe it didn't click with me the same way that it did with other kids. So, even to my point, I guess technically, what I'm saying is I'm even mislabeling myself that I struggle with math. I think really my point is like, I felt that I was struggling with math, but in reality, and what I kind of found from self-reflection, it wasn't really I was like struggling with math. It's just I wasn't ready to learn what I needed to learn. I didn't fit the pacing of the instructor or of my classes or of my tests. It seemed like I always joke with some students, because I know some people have felt this way. Like it always felt like once I took the test, I always understood the material like 2 weeks later. Like it was finally be like, I do poorly, get a C or D or whatever on a test. And then it'd be like 2 weeks later, once we'd be doing something else, then my brain would finally make the connection. And then I'd be like, oh, now I get it. Like now I understand. And it's like, oh, now I want to go back and take that test, and it was like a very frustrating thing. Like I always just felt I was just behind. It wasn't like I couldn't understand the math. It was just, I was like delayed in being able to make those connections. And sometimes, we can devote those to like the practice, definitely was not getting as much practice as I probably should have. But then also like some of the, experiences, life experiences or, schooling experiences that you have to be able to make those connections. So those are just some different things that I think about when I'm teaching, especially when I'm dealing with students that say they're not good at math or say they struggle with math or they hate math, and really trying to, think of ways to, help them be successful and not, turn into just using a label as an excuse for, letting math be a difficult topic for them. All right. How do you think about calculus in order to learn, since the gap between algebra 2 to pre-calc and calc is so different? Do you also derive equations? I'm not really think about the order of calculus. I think that, I'm trying to think of your question, since the gap between algebra 2, pre-calc, and calc is so different. Yeah, I mean, I think definitely we need to, one of the things that a lot of that's going on is us being able to step back and do a lot of this distance learning is it's, hopefully one of the byproducts would be us allowed to really, revisit what are we teaching? Why are we teaching these students? I think for right now, it's kind of like, oh, let's just get through the year, get these students something. But in reality, it's like, what are we trying? Why do we want students to learn this material? Like, why are we teaching them this math? And again, I'm a big math proponent, but I'm also, I'm also a proponent for drastically changing the way that math is taught inside the classroom. If we're going to be doing this distance learning, I don't think we need to be as abstract for so many students in the algebra 2. Like obviously we want students to go into calculus. Like calculus is beautiful and we want students to be strong math students, but we have to push those students into those and we have to, push them mathematically. But in the same respect, not everybody needs to go and take calculus, or at least at the high school level, right? But that's not saying, I should take that back, but we don't necessarily need to take like the AP calculus level. I think there's definitely some elements of calculus that everybody can learn and everybody would benefit from learning. But that's only going to happen if we really kind of relook at how we're teaching mathematics and the stages that students are going into. There's been a lot of proposals that I've been very interested in. I've just been kind of watching what people have really been doing that are trying to, change the way that math is taught, or at least the progression of mathematics. Definitely a lot more push into discrete mathematics as well as into statistics. And I think those are some really interesting and interesting and important topics that we really need to start looking at. And again, there's really been no reason to change things, but I think what's going on now might be something that we're going to start relooking at here in the next couple of years, which hopefully kind of makes it a little bit excited because I do think as far as, preparing students for the future and, for life, what we currently are doing is very outdated. Do I derive equations? It depends on my lesson, what I'm doing. Sometimes I'll go through the equation. Sometimes I will not. Mom said, can you kindly let me know if you would be revising trigonometry involving basic identities anytime soon? I'm not sure what you mean revising trigonometry or maybe reviewing my trigonometry. No, I'm not going to like go back and review all of my trigonometry identities. I mean, I do have a whole bunch of videos on trigonometric identities. If you just look on my pre-calculus playlist, I mean, I have a ton of identities: simplifying, verifying, double angle, sum and difference, half angle, all of those kind of identities. So it's kind of a lot to like review all of that, especially at this time. But if you do have any questions, I will try to work on getting that Discord up. So therefore you can submit those. And then obviously I can do those for streams next week. All right. Okay, let's just go and see. Do I have any reviews on geometry? I'm not sure you mean on reviews on there, but I do have geometry videos that like review topics, but I don't have any like semester reviews or final exam reviews. That is actually something I was planning on doing over break until this whole virus thing kind of took over, and therefore state testing got canceled at our school or across our state. And therefore then it just became really less of a need for me to do a whole review packet, because I did the review packet for pre-calculus last year and it took me like an hour and a half, 2 hours to go and work through it. It was a lot. It's good. And I'm still going to like repost it back up for anybody that does have testing for pre-calculus. But yeah, it was a lot to go ahead and handle. So, D1C. No, I don't think I have one, Justin, for the cotangent. As I kind of mentioned, that's one that I think I said at the beginning. That's not one I went over. So if you just send over what you have on there, I can go ahead and take a look at that. But I think you'd have to go and look at using the reciprocal of the tangent function, just reciprocating that. But I have to go and take a look at the formulas again, go from there. But I'm pretty sure if you just go ahead and take a look at reciprocating the fraction, then you could go ahead and evaluate. Because again, just got to think like cotangent is equal to tangent. So if you had, and again, this would be fine. Like if you had, like if you're trying to think cotangent of x over 2, right? Well, just remember that's the same thing as 1 over the tangent of x over 2. So whatever the half angle formula, whatever the formula is for tangent, just put that over 1. And then you could go ahead and flip that over, or just basically flip the numerator and denominator and kind of go from there. No, Kevin, you cannot go to the bathroom. All right, guys, but I think that's just around the 9:30, and we're very happy to be able to help you out. Justin, other Justin. If you're worried, don't answer a question on exam, but know how to do it afterwards. Actually, I got a couple more questions. Sorry, I forgot to do this. Like personally, I find it difficult vision how to apply derivatives into a real world application because I'm just not sure how to use the equations in the real world. Does that make sense? Yes, it does make sense as far as how you would apply the derivative, like at least the mathematical application of that. I think, first of all, as far as like a lot of mathematics, I think just understanding the visual approach and visual understanding of the derivative and what that does, especially when you're looking at like, particle motion problems, you can kind of see how that works out. But in reality, for a lot of like the pure math, which is more of my interest, understanding that derivative and what that gives us in terms of the function is, that rate of change or that instant rate of change at that given point is kind of like what is the importance and how that can be further applied. Obviously, if you're looking for like more of an application sense to like understand the derivative, looking into like a calc-based physics is going to help you see a lot of those like firsthand applications of what the derivative is telling you, for instance, like, velocity and acceleration and, all that kind of stuff, dealing like with a lot of motions and stuff like that. So I would definitely look into a little bit more applied if that's what you're having trouble, with. But again, like not everything in especially in calculus or even in math is always going to have like that simple, like this is exactly how it's used in the real world, or think about it in this terms, because everything is not really that connected or like a direct application. Derivative though is a derivative, integral, those two fundamental ideas of like calculus do have their very direct application, to real world, which sometimes in math textbooks, for the calculus textbooks, the problems or examples are not going to be as well seen as you might see in like a physics course. And have you ever had a moment when you don't know the answer, I'm assuming, to a question on an exam, but you know how to do it afterwards? Yes, of course. I wouldn't tell my students that, but maybe they're listening. But yeah, of course, I've done a problem. Actually, I even did it this year, where I did a problem and I did the problem wrong, right? Or, I do it all, that happens all the time. I'll do their exam and I'll make a mistake, or I'll even get stumped on it. I'm like, what did I do? And I can't think through the problem, even though I already created it, and I'll confuse myself. It happens all the time. And that's why I always tell people, I'm human. I am not a math master. I've done a ton of math problems. I enjoy teaching. I enjoy mathematics. I enjoy learning, and I enjoy helping others. And so I bring all those together and I do the best I can. But otherwise, guys, it has been a great week sharing my live streams with you. And unless anything changes, I plan to be back with you for open Q&A on Sunday at 9 p.m., where hopefully we'll have some questions. We can go ahead and knock those through. And then also I'll just kind of plan on just doing a quick little 30-minute check-in with you guys throughout the week. And if you do have some questions here or there, I'll be able to answer them. Otherwise, I'll kind of keep you guys, as well as my own students, updated on what's going on, what they need to expect. So otherwise, guys, you guys have a great weekend, and I will check back in with you on Sunday. All right. Night.